Today I am going to be talking to you about building data science fluency in your organization. My own experience with this is at Chevron, where I created introductory data science classes to be taught throughout the enterprise. I led the data science development program, an internal program for developing data science talent at Chevron. And my current role is kind of expanding on that, looking at all things digital, which includes not only data science, but cloud, Internet of Things, and sort of all digital technologies kind of more broadly. And so some of the messages are kind of the same, whether you're talking about digital or data science. So the expectation, and I'm guessing why a lot of people are here, and you know there's a lot of interest in using data science to create value. And this could be in terms of making more money, improving people's health, just anything that can make our lives better. And with advances in technology, it's easier to collect, store, and analyze massive amounts of data. Sensors are really cheap, so we can collect data like we've not been able to collect it before. And there's all this excitement about what we can do with it. However, and I've been in meetings where I've heard messages like this, where we were told that it's as easy as pushing a button and getting an answer, and all these fantastic things will fall out, and you'll get lots of value from it. Unfortunately, the reality doesn't really work that way. There's really no easy button that you push to get an answer to all the questions that you did and didn't ask. And what often happens, in my experience, is that if you have a data set and you try to find something that's interesting, it may or may not actually be anything that's useful, or it may be interesting to you and not interesting to anybody else. So the challenge then is to avoid a lot of pitfalls that are involved in using data science and making sure that you're actually getting value for the resources that you're putting in to try to get this value. Before I start talking about building data science fluency, I want to level set on the definition of data science that I'm using. And this will really lay the foundation for some of the strategy that I use when I'm thinking about building data science skills. So the definition I like is very, very broad, and what I'll use here. And it's that data science is an interdisciplinary field of processes and systems to gain insights and extract those insights from data. So very, very high level. And a lot of the focus is on kind of the machine learning and the analysis and the analytics that goes on here. But the point of doing all of that is to get information and insights out of your data so that you can make better decisions and solve challenges. That's the goal. And so I want to focus on that second part of this definition, which I think of as being the why. Why data science? So it's helpful to think about what success looks like before you start planning on how to get there. So thinking of beginning with the end in mind. And the thing that I think what characterizes success is not just in finding insights, but finding insights that are new. So things that we didn't know before that can be discovered through data science and through using our data and looking at it in a different way. But if we're interested in something that is not purely an academic exercise, and we need to kind of justify the resources that we're putting into creating data science tools and using data science, we want to make sure that those insights are actionable and implementable. So it's not enough that the insight is new and useful and interesting, or is information that could be used to make a decision. You need to also make sure that you could take action on it, and that's clear what action should be taken based on that information, and that you can implement it in a way that makes sense in whatever context you're looking at. So an example of this, I think of this as a classic example. I always use it for this. You might have seen this, is the Netflix prize. The Netflix prize was a prize that Netflix put out. They did, I think, a couple of years in a row, where they put their data from their recommendation engine and asked people to submit algorithms to improve on the recommendations. The last year, or maybe I think the second year also that they had the prize, there were winners that created an algorithm that improved the recommendations by 10%, which sounds really great. However, when Netflix went to look at implementing the solution, the engineering costs were so great that they didn't actually use the algorithm. So people got to keep their money. I don't think they took back the $1 million, but Netflix had no need to actually use it. So that 10% increase was not enough to justify the resources that would go into actually implementing this algorithm. And so then that's the challenge then when we're looking at using resources and trying to implement these solutions, is that you need to think about what constraints there are and whether or not the solution that's being put forth actually matches those constraints. It could be money, it could be time, a variety of costs. And so having that incorporated right from the beginning is very critical. So it all gets back to having the right information coming out of this process so that you can be successful. And success I think of as depending on three main criterion. And I think of it as like a three-legged stool. So if you're missing any one of these three pieces, you're going to fall over and you're not going to be successful. You're not going to be able to stand up whatever it is that you're putting out. First, and I go back and forth between all of these three about saying which one is the most important. So I usually start off when I go thinking the first thing, the most important one is thinking about what question it is that you're trying to solve. You can have all the data in the world, but if you're not asking the right questions, it's not going to do you any good. You'll get the results like that Dilbert cartoon showed you. And of course, you need to have the right question, but if you don't have data, you can't answer the question if you don't have the right data. But often the right data follows from the right question because we have so much data out there that you need to make sure that you're getting data that's relevant to answer the question. And whenever you're thinking about this in the context, say, of a business or an organization where you're getting resources to do data science, last but not least, and I go back and thinking that this might actually be the most important factor of having the right sponsorship, having management support for the resources that you'll need to do your data science project, for having all the right people involved in the project, for getting access to the data, permission to use the data, and then all the different tools that you might need to do the data. And sponsorship, I think, of really kind of broadly speaking. Of course, having management support is important, and having the resources and people to do the project, but also thinking about who are your end users. And if you create this tool and no one uses it, it's not very successful. So thinking about this more broadly in terms of maybe stakeholders. Who do you need to incorporate what their needs are so that you will produce a solution that is actually useful and successful? I like to take questions during it, so I'll stop real quick. Are there any questions about what I've done so far? Or thoughts? Yes, back here. I'll repeat you might have that.
Yeah, I've followed the Netflix algorithm challenge for a few years.
Yeah.
And a lot of them are revolving around, say, an SVD, like a singular value decomposition.
Okay.
I'm kind of thinking what kind of a challenge they had in implementing it, because it's a fairly simplistic one where you have the genres and then you have their likes. So I'm just a little curious.
I'm not sure, but there's this the link right here. If you wanted to trace that back, I'll just point you there to kind of tracing it back and seeing maybe what it was. So the only comment I can make kind of with knowledge about that, I guess, is that Netflix is in the business of making money. And if they thought that the costs of implementing that algorithm would be justified by the money that they would make from implementing that, then they would have done it. But somehow they didn't. So, and they have a lot of resources. They're a pretty big company. So they still decided not to. So I don't know. I can't answer that. But that would be my only comment on that. All right, so kind of thinking about all the different elements that need to be in place for a data science project to be successful, it starts to point to the second part of the definition, and that this is an interdisciplinary process. And interdisciplinary in the sense of different disciplines, the knowledge that is incorporated from different disciplines to actually work on the project, but also in terms of the people that are needed to give input on the project so that we can be successful. So the data science process then, very, very broadly, kind of looking at it very, very high level, I think of it as having four main parts. This is my husband. This is us on a trip. He's trying to figure out how to get where we want to go. And that's really what this process is about. Like, where do you want to go, and how do you get there? So starting off with the question, making sure that you're working on the right things. What decisions are you trying to make? What questions are you trying to answer? And then after understanding that, getting the data that will help you answer that question, getting permission to access it, getting access to it, getting it, cleaning it, doing all that sort of thing, preparing it for analysis. Then doing the actual modeling, kind of extracting that information, and then after you have some results, communicating those results, and hopefully using them in some way, implementing them in some tool, deploying them to a workforce that will be using the output of whatever's been created through the data science project. So thinking about the capabilities that are required to execute these different steps in a process, it starts to point to the idea that maybe not one person is going to have expertise in all of these areas to be able to execute a project successfully. So when we think about who is the person who has the best knowledge to understand the question, it may or may not be the data scientist. And it could be for simpler projects that expertise in all of these areas will reside in one person. But when projects are more complicated, when questions are more complicated, it's often going to require a team of people. So the people that have the most knowledge of the question, the decisions that need to be made, are the domain experts. Again, they may or may not be also data scientists, but they're wearing a different hat of understanding the context of the data, understanding the subject matter, and sort of the different challenges around the question and the challenge that we're trying to solve. Then the next part of getting the data, I call these people in a very big bucket data strategists. They could be database architects. They could be data engineers. You know, there's a wide class of people that fall into this bucket. But these are the people that I think of who actually have access to the database. They know how the data is collected. They know how it's stored. And they are able to collaborate and give you that information so that it can be processed appropriately to do analytics on it. And then the data scientists, I think of kind of taking the primary role in the modeling step. So not saying that they're not involved in any of the other steps, but they take kind of they're in the driver's seat for this role right here. And then after a solution has been proposed, some results have come out, thinking about how you're going to implementing it, and this is very broadly, probably everyone is going to be on the receiving end of some sort of a data science tool or solution that they're going to use, hopefully, to make their lives easier. And all of these people are going to have to be able to talk to each other. Again, it's not going to be one person that's going to be doing all of these things. There is a collaborative effort that goes on, and collaboration requires communication and understanding. And so that's when we start to get to some of the strategies around data science fluency of thinking about this like a language that we need so that people can communicate with each other and be effective. So what is fluency? So fluency, thinking of it like a language, is the ability to write or speak a language easily and accurately, so that you know enough about that language to be able to do what it is that you need to get done. wherever you are. And if you think about this kind of practically speaking, the fluency that you need might depend on what you need it for. So again, using language as kind of the context, if you're going to visit, say, I go to Italy a lot. I spent a semester in Italy, and I had to learn the language well enough to get around, but I didn't really need to know technical language. I didn't need to know medical terms. I needed to be able to have conversations with people. I needed to be able to ask for directions and get where it is that I needed to go. Now, I have friends that now work there. They liked it so much there, they stayed, and so they speak the language fluently at a level that is not really required if you're only going to spend a semester there. And then if you're, say, in a more technical field, you have to have a deeper knowledge and maybe more specific knowledge of language and terms around that to be able to be effective. And then if you're only going to be, say, in that foreign country for a couple of days or a week, it might be nice to learn more about the language, but maybe all you need are the pleasantries and enough to say, I don't speak the language, do you speak English? Whatever language that is. So there's not really a need for you to master a foreign language if your interaction with it doesn't really require it. You can definitely do that, but when we're thinking about what is necessary to be successful, it really depends on what it is that you need to know that language for. So same I think, with data science. So kind of thinking about, I guess this is my own opinion and my perspective of what I've seen over the last 5 to 10 years, depending on when you think data science became a term, whatever that was, is that in the beginning, there was the idea that data scientists would do everything. And data scientists could frame the problem, they could clean the data, they could run all these models, and then they were writing software and code to execute it, and it was all in one person. And there was this magical unicorn that doesn't exist. Now, there probably are some people, and I know some people who are extremely bright, who maybe can do all of these things, but there's very, very, very few of them, and few of them to fit the need that we have for data science skills. And it also doesn't make a lot of sense, practically speaking, to expect one person or one class of persons to do everything. I like analogies, so I think of this in terms of cooking. If you had a food truck, maybe you would just need one person who could do everything. That one person could go to the store, get the ingredients, take the orders, cook the food, serve it, and then you're done. But if you're thinking about opening up a restaurant, you need the chef to be in the back overseeing the food prep or cooking food. You need to have servers out front who are serving the food. You need to have people seating your customers. And so really when you think about this in a more complicated setting, it makes a lot more sense to not have one person doing everything. And it's the same with data science. So as tools and technology become a lot more available, statistical software, programming software is easy to come by, and you can run it on your computers. We have access to all this technology. There starts to be the idea and the message that everyone can be a data scientist. And I've sat in on a lot of vendor meetings. Oh, sorry, I might want to offend anyone, but it has been the case where the message is, all you need is this tool. Just give everyone this tool, teach them how to use this software, and everyone can be a data scientist. It doesn't always work that way. So think about it again in terms of cooking. I mean, you might have a fantastic equipment, and it still doesn't necessarily mean you're a Michelin star chef, and that's okay. So maybe it is that you need what you can do what you need to do to get your meal served, or to create, to serve. Maybe you can serve your family at a family meal, or maybe you have the skills to do even more than that. But there's sort of different levels of skill required depending on what it is that you need to do. And pushing a button on a microwave and cooking food doesn't mean that you're a chef. So same way with data science. So then the idea or a strategy for thinking about when you're building skills in your organization, building competencies around data science, is to think about them in terms of the role that the person will need to take in the data science process. So I've kind of grouped these into three main categories around data science competency, but really you can divide these up any way that you like that's appropriate for you. And the first group that I want to talk about, which I think everyone would probably be concerned with, is everyone. And so very broadly speaking, we want everyone in the company, so I'm thinking again in my own company at Chevron, to be aware of what data science is, to understand maybe what it can do for them, and to be inspired to think of how they could use it to make their lives better, to make their work easier. And so some of the things that we've done in this space at Chevron is making sure that we publicize success stories. And success stories that don't talk about the technology or the analytics that was done, but focus really more on the people aspect of what it was that could be done because we used machine learning, whatever kind of analytics we're using to make people's lives easier, to make our work safer, to bring down costs, and to gain more value. And then for domain experts and strategists, we might need something that is a little bit more technical than, say, everyone, because they're going to be working much more closely with data scientists. So we want them to be able to understand the communication that needs to take place to translate the business problem into a technical solution. And we don't need them necessarily to understand, what random forest is or support vector machines, but be able to be willing to have that conversation to talk about what characterizes success for them so that it can be translated appropriately for the data scientist. And in this space is where I think of maybe a more in-depth introduction to data science, which is something we have at Chevron, where we go into a little bit more depth about what that process actually looks like so that they're able to be more effective participants when they are involved in that process. And then data scientists. So I have them up here. So you would think that data scientists already have data science fluency. But the thing that I often see that data scientists or people who are put into data science roles who are coming fresh out of school is the understanding of the need to translate the analytics that they've learned into business solutions, and to be able to think about well, yeah, it's a translator sort of a position. So it's not enough to say to someone, oh, you need to do reinforcement learning. Thinking about what characterizes. So what I'm thinking here is there's often a lot more soft skills involved in this part of it. So there's some business acumen that needs to be learned, some more customer-facing sort of skills that are helpful in this area too. So that's not technically around data science fluency per se, but it's something that can be learned to help facilitate the execution of that process. And a group that I don't have up here is leadership. that I was kind of thinking about after I already submitted it. I don't want to change the slides. Thinking about leaders as maybe in a separate group from all these other people, and that they may or may not have technical knowledge, but they really need to be supportive of this whole process in terms of championing it, just saying that they support it, maybe helping to set goals of what it looks like when they're successful, but also knowing enough to get out of people's way and hiring the right people and putting them in the right places to allow those people to be effective and to be successful. Let's see. What questions or thoughts? Actually, I have one more slide. I just realized I did that, and then there's a question right back up here. So my final thoughts in all of this are when you're thinking about fluency and you're thinking about building skills in an organization, it's not necessarily one size fits all, and to think about what it is that needs to be learned so that people can communicate with each other more effectively. And I'll just leave you with this one picture. I have a corgi. He's 1.5 years. We do lots of training with him. And the thing that I remember the most when we started our training was that our trainer said, "Your dog does not understand English." Obviously not, right? But when you think about it, I think sometimes we communicate with each other in a way that if we say it more often and we say it louder, that someone's going to be able to understand us. It doesn't work with dogs. It doesn't work with people either. So just saying you should just understand why this is important is not enough to really get buy-in. Think about what your audience needs. Think about who you're communicating with, and tailor your discussion appropriately. So with that, I'll open it up for questions. Thank you.
Does the data scientist need to be a domain expert?
Does the data scientist need to be a domain expert? I don't think so. That's not, no. I would say no. I think that they need to know enough to be effective and to have credibility with the domain experts that they're working with. And so for example, in my own space, I focus on process safety in terms of the types of projects that I work on. And it would be, and I've worked in a lot of different places, but I have a certain level of expertise, not as deep as people who are, process safety engineers, but enough that I can not have to relearn everything once I'm starting off. It can be helpful, but I don't think it's necessary.
Do you have any other questions?
Hi, Sanjay Dhamija. I'm with Embassy of Things. Thank you. That was very enjoyable. There's just a quick question. Where would you rate data science adoption is in a company like Chevron or any of these big oil and gas companies? Are we still experimental, sort of kicking around things, or is this, where are you to become ingrained with, business planning processes and people trust this, and you have the ear of your operational folks that want to talk to you before they make big decisions?
Okay, so how I'm understanding it is understanding kind of the level of integration of data science into the way that we do business, kind of. And so I can speak from my own opinion about Chevron, and I see some of my colleagues in the audience. And then I have friends at other oil and gas companies too, so I won't say as much about that, but I think it's a similar experience in that from what I've noticed over the last maybe 5 or 6 years, that it's gone from more push to pull, meaning that we don't have to convince people so much that there is something that we can do to help make the business more successful, and that leadership is on board and wants to start supporting it. So now it's really a question of what that actually looks like. We don't need leaders necessarily to say, go do machine learning, but what is it that needs to be given so that people can be successful? And then in terms of adoption, it varies really it varies by function and varies by business unit. And so maybe some functions, say like engineering, that are really more technical, the adoption will be a lot quicker than I started in HES and don't want to offend my HES colleagues, but health, environment, safety, maybe there's a little more resistance just because it's not as much part of their formal training, so there's a little bit more, not as much readiness to adopt. But what I see in the last few years has been really a huge step change in a willingness to adopt these sorts of technologies. My own opinion. Yeah. One last question here. Yes.
So I want to ask your opinion about data acquisition, especially in terms of traditional industry and traditional companies. What efforts are you currently involved in strategically acquiring data?
So are you thinking of external data or internal data collection, or just if you can clarify that a little bit for me?
Yeah, I work in the healthcare industry, and currently the data we have are primarily clinical, and so we don't have genetics data, we don't have a lot of health behavior data or social determinants of health. So I wonder if you face the similar challenge of...
Yes. Okay, and so correct me if I'm not understanding it right. So it's often the case that we find that we want data that we're not actually collecting, and we have to figure out how we can get it. Is that sort of the type of problem you're talking about? A little bit, yes. So that's definitely happened. So we have lots and lots of data at Chevron, and the challenge, I won't say problem, it's just the challenge is that when this data was set up to be collected, it was not collected with the purpose of doing analytics. It was collected, say, more for monitoring a process. And so it was, maybe everything that was needed wasn't recorded. And I've been in projects where there was a certain outcome that we wanted to study, and we thought, oh, wouldn't it be cool if we knew this, that, and the other? And we looked in to see how the data was collected, and it just wasn't collected. And so that's part of having the right question, because that will tell you what the right data is that you need to collect. And so what happens in that case is that we go back, we set up a mechanism to collect it, and we have to wait some time before we get it. But that's sort of ongoing. And what I've noticed is there's an awareness of that happening, is that I've been more involved in projects when databases are being set up, like right from the beginning, of having brainstorming questions before we even start collecting the data of what kind of questions would we like to answer with this data. And that can help determine what kind of data we collect so that we make sure we have it when we want to ask those questions.
Join me in thanking our speaker again.
Thank you very
Thank
much.
you.
Thank you.